So I did what the book told me to do for 3.2.1.a. I don't know about you though, but I don't feel like I taught that lesson well. I also don't feel like the book put it together very well. So what I did is I have a piece of paper that's got all these problems on it, and we're going to do them together. Okay, I'm going to use Desmos to help. So this one, and I want you to see the relationship between them. I would go down 3, up 1, right 1, up 1, right 1. I make my line. Okay? So we've done that before. This one, I would still go down 3, up 1, right 1, up 1, right 1, but it would be dashed. And since it's greater than, I'm shading up. So I want you to look at the difference between those two. Now, these are both lines, but as soon as we see absolute value, we know it's going to make a V. So that means I need to find the vertex, 3, 0. So I would go right 3, and put a little line there. And the slope happens to be 1. Up 1, left 1, up 1, left 1, up 1, left 1, up 1, right 1, up 1, right 1, up 1, right 1. Okay? So we have these 3, and now what I'm going to do is I'm going to go over to Desmos, and I'm going to show you how they relate to each other, okay? So escape. All right, so the first thing I did is, let me put this in the right place. I graphed y equals x minus 3. Now what I'm going to do is I'm going to take that off, and I'm going to graph y is greater than or equal to 3. So it's the same thing. Look at this. It's the same thing, except it's dashed. Greater than means it's shading up. So all of this is a solution. All of these points are a solution. Let me go back to this one. What's a solution? 0, negative 3. What's a solution? 2, negative 1. What's a solution? 4, 1. Anything on the line. But then this one, I say, okay, what's the solution? Well, anything in this gray region. Now, if you tell me 3, 0, no, it's dashed. It is not part of the solution. So I have many solutions, and here I have many solutions, but they're different types of solutions. Here you would say anything on the line is a solution. Here you would say, okay, anything above the line but not including the line is a solution. Now I'm going to do this one. Oops, maybe I'm not. And look what happened here. Do you see that part of it was x minus 3? The other part is negative x plus 3. Because when it's absolute value and you drop the bars, what do? You do the opposite. The opposite of positive x is negative x. So let me see if I can add something in there. Nope, it's not going to let me. So if I went like this and I went negative x plus 3, and I turn that off and turn that on, like, do you see how that? So if I have y equals x minus 3, let's put both of those on. And then if I go this now, it's right over it. Okay, look at that. Do you see how that's over that? So I wanted you to see how those relate to each other. Okay. All right, let's go back here. My computer's being fun. It wasn't that bad this time. Okay, now let's go to absolute value. We know when it's absolute value, we have 2 answers. What do? We split it. What do? We split it. So x minus 3 greater than 5, x minus 3 less than negative 5, x minus 3 less than 5, x minus 3 greater than negative 5. So I'm going to highlight this because this is where you have to switch it and make it negative. And then, let me zoom it in a little bit. Sorry about that. I get x is greater than 8, x is less than negative 2. X is less than 8, x is greater than negative 2. Now I graph it. 8, negative 2. 8, negative 2. Open circle, open circle. Open circle, open circle. Okay? Now when I look, let's see, greater than 8, less than negative 2. So my answer graphically is this. My answer algebraically is this. So I'm cool if you give me any number bigger than 8 or smaller than negative 2. But you give me anything here, not going to be happy with it. Okay? Let's do this one. Less than 8, greater than negative 2. Oh, so it's everything in the center. So they're not ors, they're one thing, they're an and. So how would we, let's do the third one, and then I'll express all of them on Desmos. Can I split this? No. I can't split it because I have to get rid of the 1. And then I have to get rid of the 2. Now that I have just bars, I can split it. So do you think number 6 looks like number 4 or number 5? Well, hopefully you think it looks like number 4. Let's see if I can find another pen. Because see how this is greater and greater? They will be similar. So that means my answer would be x is greater than or equal to 8, or x is less than or equal to -2. How would that be graphed? 8, closed circle, -2, closed circle, away from each other, away from each other. So now I'm going to show you on Desmos how they relate to each other, okay? So let me get out of here. I'm first going to show you this one. Now it only knows it as x. So since it only knows it as x, it's saying, okay, I'm only focused on the x-axis. Do you notice it's everything shaded over here and everything shaded over here? I want to show you, what if I did this? -5y. Look at that. Some of you go, what just happened? Okay, I wish I could add something. Let me see if I can. Let me do the original one. Okay. Oops. Oops, and I gotta show it. Do you see how those relate to each other? Look at this. When there's a y in there, you go, it's an absolute value equation. Blue. Okay. And when it's just an x, it doesn't register it as being absolute value, an equation graph. It's just only the x values. But what are true? This way and this way. Now, if I was to move this over, let's say I switched the x and the y. So now the y's over here and the 5's back over here. It's the same thing. What if I rewrote this, but instead I switched it and I went less than absolute value of x minus 3 plus 5. Let's see, oops, I might have done that wrong. So I'm switching them. It's the same thing. Okay, so whether you go forwards or backwards. What if it said y is greater than? Well, let's look here. Less than. Okay, let's see if I can find it. Where did it go? Oops, I've got too much happening here. I'm sorry. That's why it was confusing. And then plus 5. Okay. I don't know where it went. Something happened. Oh, silly me. Okay. So now, if you look at that. They have points of intersection in the center. This was the one where you had the and. It was shaded in the middle. And then now this one, I said, looks like the first one. So if you look here, let's take away this and let's take away that and make that greater than. It's the exact same thing. It's the exact same thing. So if you go like that, see? Same thing. So I want you to see how they relate to each other. If I have a y, suddenly it looks like the shape that you know it is. Okay. All right, let's X those out now, and then we'll get to the next section. Okay, now this chapter was all about everything quadratic. So if I asked you to graph this, you would magic exit, and you would go x minus 3, x plus 2, 3, and negative 2. And then you would graph it at 3, and you would graph it at negative 2, and then you would go halfway in the middle. There's the vertex, and you would graph it like that. Okay, I'm faking the vertex. This thing, you do the same thing, right? Okay, 3, negative 2, faking the vertex. I'm not very good at this. Oops, but it's got to be solid. And if it's greater than, it's shading up. Now, this one's different because it's saying, hey, we're not dealing with y this time. We're only dealing with x. So in a sense, I'm going 0. I don't know why I'm putting the 0. 3, negative 2. Open circle, open circle. Now we know if I fake drew the parabola and I change this to a y is greater than. Right there. Which means I'm actually shading in the middle. So that means it's -2 is less than x, which is less than 3. Or if I showed that, 3, -2. Now, what is the difference between this one, and this one? What does this have that those don't? A y. A y. Since it has a y, it knows the shape. Since it has a y, it knows the shape. Since it doesn't have a y, I fake it, put a y there, and see where it would go. Okay, so let me show what that means. Let's come over here, go to my graph. That worked out pretty well. All right, there's my graph. It crosses at 3 and -2, and my vertex is down there. That, right over it, dash. So same thing, right? Now this one I'm saying, okay, it's not a parabola anymore. I'm just focused on the x values, and I want the x values to be here and here. So what if it said, instead of greater than, it said less than? Then it would be x is greater than 3, x is less than -2. What if I said this? And let's take off this, and well, maybe I'll just leave it blank right now. Okay. Well, I would go, okay, this is really with a y, oops, but then it's backwards, so I make it forwards. And it's the same thing. And look at that. There's my u, it's in the middle. There's my x, it's in the middle. This one again would be an and. Okay? Let's go back to the screen. Now let's go to this one. Okay. I'm going to give you these two. If I asked you to graph these two, which I want you to see back in Desmos. So if you look here in Desmos, I graph this one and I graph this one. If I said find the points of intersection, then the answer would be whatever, -2, 15. Look at how it wrote down, and 3, 10. So if I said, hey, tell me where they intersect, what would I say? -2, 15 and 3, 10. -2, 15 and 3, 10. So you would graph it. Let's see, I'm faking it. I don't remember what it was. Whatever. That's 3, 10. And that's -2, 15. Now, if you were solving it, you would do this. 2x squared minus 3x plus 1 equals x squared minus 2x plus 7. You would take all of this and move it over and get x squared minus x minus 6 equals 0. X minus 3, x plus 2, 3, and -2. X value, x value. Look at that. 3 and -2. But what I'm asking for now is, what if I did it and I said less than? So let's go over here and let's see the differences. So what I did is I said, okay, I'm putting this here and I'm putting this here. So now I'm going to show you this. And what it's saying is, if you look, whoops, let's see. There's my 3 and my -2. If I gave you that, you would say x is greater than 3 or x is less than -2. If I was to graph this, I go x squared, oops. What did I say? Minus x minus 6 is greater than 0. It's the exact same thing, isn't it? And then if I did this, and I control V that, but change that to a y, but now it's backwards, I want to make it forwards. It's the exact same thing again. And if it's equal, it's back to being solid. Okay? Hopefully you can see the relationship between all those examples. I want to open this up really quick so you can see how they all kind of relate to each other. So let me zoom that out. This was me kind of winging it because I didn't really like the lesson. Okay? Hopefully that made a difference.